Solving systems of equations by graphing. A system of equations is when you have two equations, and what you're looking for when you solve a system is the ordered pair that makes both equations true. In other words, it's a solution to both equations. The solution to a system of equations is the ordered pair that is a solution to both equations. It makes both of them true. There are several ways to find a solution to a system. Graphing is the first, and here are the three possibilities. The first thing you need to understand is that when you graph a line, you're graphing every ordered pair that is a solution to the equation. So when you graph two lines, you graph all the ordered pairs that are solutions to both equations. Where they intersect is the solution that works in both equations. So this ordered pair, if I plugged it into the equations for both lines, would make both equations true. However, it is possible that when you graph both lines and you have all the solutions to both lines, they don't have any in common. They don't intersect. They're parallel. In that case, you get no solution. And it's possible also that when you graph both lines, they overlap. So here there are two lines. It doesn't look like two lines, but there are two of them, and they overlap, and they intersect at every ordered pair. So there are infinite ordered pairs that would make both equations true. They're infinite solutions. Most of the time, when we solve a system, we're just going to get one solution. For this assignment then, all you have to do is graph both lines and name the ordered pair where they intersect. That ordered pair, if you plug it into both equations, will work in both of them. It'll make them both true. In question 1, there were two lines and you graph them. We don't have the equations. But when you graph them, they intersected at the point -2, 5. So this would be the solution to the system. Now understand the graph is how you get the answer. The actual answer here is -2, 5. This ordered pair, if you plugged it in the equations for both of these lines, would make them both true. In question 5, we have to graph both lines. The first one has an intercept of 3 on the y-axis, y equal mx plus b, b is the intercept. The slope is -2 over 1, so I'll rise -2 and go down 2 and run +1, and then I'll draw my line. The second equation has an y-intercept of -2 and a slope of +1/2. So we will rise +1 and run +2. Rise 1, run 2. Rise 1, run 2. Draw both lines and find the solution, the ordered pair that makes both equations true. That's this ordered pair, x is 2, y is -1. Make sure you enter parentheses when you enter it in WAMAP. For question 7, we have a slope of 3/2, an intercept of 2 for our first equation. Plot your intercept, rise 1, 2, 3 over 1, 2, up 3 over 2, and you could also go down 3 and left 2. Draw your line. The second equation has a slope of -1, an intercept of -3. Plot the y-intercept. The slope is -1 over 1. That's rise -1, down 1 over +1, down 1 over 1. Or you could go up 1, left 1, up 1, left 1. Draw your line. The solution to the system, the point that makes both equations true, is the ordered pair -2 for x, -1 for y. So enter in the box, I don't have it here, but it will be -2, -1. And again, make sure you do parentheses. Remember that there are three possibilities. The lines might intersect in one point and have one solution in common. They might be parallel and have no solutions in common, no solution. They might overlap and be the same line, in which case they intersect at every ordered pair and there are infinite solutions. In this case, both equations are the same. Let's graph the equation. That's part of the problem. The intercept is +1. The slope is 2 over 1. So rise 2, run 1, rise 2, run 1. Make sure you only do 2 points in WAMAP, otherwise it gets confused. I tested the question on this problem, and you actually don't have to graph two lines because they're the same line. You can. When you graph a line, just make sure you choose 2 points and use the line tool. The solution here is that there are infinite solutions. This is a symbol for infinity. It's a sideways 8. To get that using the keyboard, type little o. For question 11, we have a slope of -1/4 for our first equation and an intercept of -3. Put a point at -3. -1 over 4, I normally move the negative to the top, but you can move it either place. Just don't put it on both. Then two negatives would make a positive. Don't do that. We're going to rise -1 and run +4. So that'll be down 1, right 4. And you may also put the negative below 1 over -4. That's the same thing. And go up 1, +1, and left 4. 1, 2, 3, 4. The second equation has a slope of -3/4 and an intercept of -1. And I normally, again, put the negative on the top, but you may certainly move it below. So I'm going to rise -3 and run +4. I'm going to start with a y-intercept of -1. Down 3, 1, 2, 3. Right 4, 1, 2, 3, 4. Draw your line. The ordered pair that is a solution to both equations is the point x is 4, y is -4. 4, -4. In our last example, the equations are in standard form. Reminder, standard form is when the variables are on one side of the equation and the number is on the other. These are both in standard form. To graph them, it's normally easier to use slope and intercept. So we're going to practice by solving for y. So this equation, -2x minus 3y equals -3. We're going to add 2x to both sides. Reminder, we put that in front, and we get -3y equals, put the 2x in front, +2x minus 3, and we'll divide both sides, everything, every term, by -3 to get y by itself. The result is y equals, I'm going to move the negative to the top, -2/3 x. Notice it's a negative divided by a negative, which is a positive, and 3 divided by 3 is 1. The second equation, 3x minus 3y equals 12. Get y by itself, move the 3x to the other side, -3x minus 3x. Remember, you cannot combine those. They're not like terms. We're going to put that in front. This is -3y equals -3x plus 12. Get the y by itself. Divide everything by -3 on both sides, every term. Terms are separated by addition and subtraction and equals. Y equals, notice the two negatives, make a positive. 3 divided by 3 is 1, so 1x is x, minus 12 divided by -3 is -4. The slope is 1 then, and the y-intercept is -4. The equation in black, the first equation, had an intercept of +1 and a slope of -2/3. That's rise -2, down 2, run +3, down 2/3. Or if you move the negative to the bottom, you could go up +2 and left -3, up 2 and left 3. The equation in blue, the second equation, has an intercept of -4. Slope is 1, that's 1/1. Rise 1, run 1, both positive. Up 1/1, up 1/1. The solution to this system of equations, the ordered pair that would make both equations true, is the point 3, -1. Enter that into the box. I believe it's below. We are going to learn other techniques to solve a system of equations, but as we go through chapter 6, always keep in mind you're looking for an ordered pair that is a solution to both equations. That's what the solution to a system of equations is, an ordered pair that makes both equations true.